In this video, we are gonna solving a problem, question number 2, IBO Challenge 2022. The figure 1 illustrated below show oxygen consumption or respiration in aqueous suspension of intact animal mitochondria with addition of ADP or chemical compounds dinitrophenol DNP or NN dicyclohexyl carbonamide. The suspension already contains respiratory substrate, oxygen, and inorganic phosphate. This is the figure 1. We can see here the x-axis is represent time and the y-axis represent oxygen concentration. Figure 1 is oxygen consumption of mitochondria in suspension. Identical aliquots of ADP were added in both experiments. So, if you don't know what is identical aliquots of ADP means, it means that if we see that plus ADP signs added in this graphic, it means that every plus ADP here, here, and here has the same exact volume and concentration. Indicate whether each of the following statement is true or false. Statement A. The mitochondria are able to incorporate exogenously added ATP. To answer this statement, we can see here at the graphic. At the graphic here, we can see when the researcher added an ADP here, we can see a significant amount of oxygen consumption. This confirms that the mitochondria are successfully taking up the external ADP and using it to drive oxidation phosphorylation. So the statement A is true. Statement B. Before addition of chemical compounds, the mitochondria respire only when ATP can be produced. So we can see here again in the graphic. In the segment before DNP and DCCD are added, high oxygen consumption occurs when only ADP is available. Once the ADP is converted into ATP, the slope flattens. We can look here. This is including that respiration is coupled to ATP synthesis. Significant respiration does not occur unless the mitochondria have the substrate needed to make ATP. So, the statement B is true. Statement C. The reason why DNP stimulates oxygen consumption is that ATP synthesis is stimulated by DNP. So, before we can answer this statement, we need to know what DNP effect on mitochondria function. Let's look at this picture. We can see here the picture of intermembrane space and matrix of mitochondria. So, how can the DNP affect the function of mitochondria? DNP or dinitrophenol is inhibit ATP system. The first thing, when DNP is added to the suspension of mitochondria, DNP gonna carry the proton from intermembrane space to the matrix bypassing the ATP synthesis. So here's how it's work. First, DNP added to the suspension, then it's gonna stay in intermembrane space. Then DNP is gonna take one of this proton. When DNP cuts this proton, DNP are gonna passing the inner mitochondrial membrane without passing using the normal gateway, that is ATP synthesis. But the DNP are gonna passing the inner mitochondrial membrane because DNP is permeable. So like here, DNP is gonna passing the inner mitochondrial membrane to here. After passing and then go to the matrix, the DNP here are gonna break the bond with the proton and leave the proton here. So here like this. And then DNP gonna go again into the intermembrane space check proton again, and then go to the matrix to release proton. So this causes the matrix have high concentration of proton, then intermembrane space have low concentration of proton. So because this affect, the mitochondria is gonna try to equalize the concentration of proton between intermembrane space and matrix. In the normal condition, intermembrane space is full of proton and matrix is low of proton. But because the DNP is added, the matrix now is full of proton. The intermembrane space are now low of proton. So now mitochondria is gonna work harder to make the proton flow again into intermembrane space. Mitochondria is gonna try to stabilize the concentration of proton using electron transport chain. So we can look here at the diagram. Electron transport chain has a final acceptor of electron is oxygen. So this is cause the increase a significant amount of oxygen. So we can indicate that statement C is false because ATP synthesis is not stimulated by DNP. Statement D. DCCD inhibits ATP synthesis. So again, before we can answer this statement, we need to know what DCC do to the mitochondria function. So we can see here the picture of ATP synthesis, which is the next stage of electron transport chain to produce ATP in the mitochondria. So DCCD is gonna bind in the F0 rotor of ATP synthesis like this. Here, F0 rotor, here or here. So when it's bind to the F0 rotor, it's gonna block the proton flow to the matrix of mitochondria. Then it's gonna stop the ATP production. So we can answer that DCCD is inhibit ATP synthesis is true.